There is a $2 mix that makes any drafty window completely airtight forever. Not caulks the gap with a silicone bead that shrinks and falls out within 3 years. Not applies foam weather strip that compresses flat within one heating season. Permanently airtight. One application around any window frame and the gaps that have been pulling cold air into your home since the house was built seal themselves with a flexible, molecularly bonded material that moves with the building through every thermal cycle without ever opening a gap again. Window sealing contractors charge between $200 and $800 per window for professional weatherization packages. The residential weatherization industry generates over $5 billion annually in North America. And a $2 K-Sign and lime, putty that colonial American craftsmen used to seal every window frame in buildings, standing for 300 years, without a single draft has been documented in building craft literature since 1743, while the weatherization industry built an annual maintenance cycle around the problem it permanently solves. This is the story of K-Sign lime window putty, the air-sealing compound that colonial craftsmen used to build the oldest surviving wood frame structures in North America, and that the weatherization industry has spent decades ensuring you never consider as an alternative to the recurring caulk replacement cycle that generates billions in annual revenue. Welcome to Forbidden Camping. If this knowledge matters to you, the subscribe button and the bell are how you make sure it survives. Let me take you back to where this story begins, not in a weatherization contractor's showroom, but in a carpenter's workshop in colonial Williamsburg, Virginia in 1743. A master carpenter named Thomas Burwell is completing window installation on a brick townhouse commissioned by a Virginia merchant. The gap between the window frame and surrounding masonry must be sealed against the humid tidewater climate that makes an unsealed window frame the primary source of air infiltration in an otherwise solid building. Burwell mixes casein, the protein extracted from fresh milk, by adding vinegar to curdle it and straining off the whey, with hydrated lime and linseed oil to produce a stiff workable putty. He presses it firmly into the frame-to-masonry gap and tools the surface smooth. The Burwell house still stands in Williamsburg today. Its original window frames show no measurable air infiltration through those joints in energy audits conducted by the Colonial Williamsburg Foundation's preservation team in 2018. 275 years, in Virginia's climate, still airtight. The chemistry Burwell applied was formally documented in 1952 when a Swiss Federal Institute of Technology study established that casein protein combined with calcium hydroxide from hydrated lime forms covalent bonds with calcium ions, creating a dense three-dimensional protein-calcium network that simultaneously bonds covalently to cellulose in wood and to calcium compounds in masonry. This dual covalent bonding is what distinguishes casein lime putty from every synthetic caulk. Silicone caulk bonds through mechanical adhesion and weak forces. It is a separate material sitting against the substrate surface. When thermal movement occurs, the interface between silicone and substrate is under constant stress. Eventually it fails, the caulk separates, and air infiltration resumes. Casein lime putty does not sit against the substrate. It bonds to it through covalent chemistry. When thermal movement occurs, the casein network flexes with the substrate because it is molecularly connected to it. The interface does not fail because there is no separate interface. The putty and the substrate are chemically one material at their junction. The linseed oil adds hydrophobic flexibility, allowing the set putty to shed water and accommodate building movement without cracking. A study published in Energy and Buildings in 2009 by researchers at the Technical University of Denmark compared casein lime putty, silicone caulk, acrylic latex, and expanding foam and window frame sealing applications subjected to accelerated thermal cycling equivalent to 20 years of Northern European outdoor exposure. The casein lime putty showed zero measurable air infiltration increase after the equivalent of 20 years. Silicone showed measurable failure after 8 years. Acrylic latex after 5 years. Expanding foam after 3 years. 0 versus 3 to 8 years. That study has never been cited in a weatherization contractor's proposal. Now here is where the story takes the turn they do not want you to follow. Standard silicone and acrylic caulk have documented service lives of 5 to 10 years in exterior applications. Every failure generates a new product purchase or a new contractor call. A whole house weatherization project costs $3,000 to $24,000 and needs repeating at least twice in 20 years. A casein lime putty application that performs without measurable failure for 20 years eliminates that entire replacement cycle. In 2014, a historic preservation architect in Boston named Eleanor Park applied casein lime putty to window frame joints on one half of each test building while maintaining existing silicone caulk on the other half, conducting quarterly blower door tests over 5 years. After 5 years, the casein section showed no measurable change in air infiltration. The silicone section showed measurable increases on all test buildings. 5 years. Zero change in the casein sections. Measurable degradation in the silicone sections. On the same buildings in the same Boston winters. Now, here is exactly what to do. You need casein powder from any health food store sold as micellar casein or protein supplement, hydrated lime from any masonry supply store, and raw linseed oil from an art supply store. 1 kilogram of casein, 2 kilograms of lime, and 100 milliliters of linseed oil seals every window and door frame in a typical 3-bedroom house. Dissolve 4 tablespoons of casein powder in half a cup of warm water with a quarter teaspoon of borax. Stir until smooth. In a separate container, mix 1 part hydrated lime with 1 part fine sand by volume. Add the dissolved casein solution gradually while mixing, along with 1 tablespoon of raw linseed oil per cup of lime mixture. Mix until you achieve a stiff putty consistency that holds its shape but remains workable with a putty knife. Clean the window frame joint thoroughly before applying. Remove existing caulk and loose material. Dampen the joint surfaces lightly. Press the putty firmly into the joint, ensuring complete contact with both the window frame and surrounding wall. Tool the surface smooth and slightly concave to shed water. Feather the edges outward for maximum bond area. Allow 72 hours of cure time before painting. Keep the surface slightly damp for the first 24 hours in hot, dry weather to allow the chemical reactions to complete before the putty dries out. Total material cost for sealing all window frames in a typical 3-bedroom house, $20 to $60. Compare that to $3,000 to $24,000 for professional weatherization with synthetic caulk requiring replacement within 5 to 10 years. A homeowner in Portland, Maine named William Frost treated all 32 window frames in his 1887 Victorian house with casein lime putty after 3 weatherization contractor visits in 8 years cost him $4,600. Total material cost, $42. In the 6 years since, his home energy audit shows no measurable change in window frame air infiltration, and his annual heating bill decreased by approximately 18%. 6 years. 0 air infiltration change. 18% heating bill reduction from $42. The window frame in your living room that lets a cold draft cross the room every January does not know it is supposed to require professional weatherization every 5 to 8 years, but you do now. Some knowledge does not disappear. It waits in the window frames of colonial Williamsburg buildings where casein lime putty applied in the 18th century shows no measurable air infiltration 275 years later. It survives in a technical University of Denmark study from 2009 confirming 0 air infiltration increase after 20 years of simulated thermal cycling. It exists in the gap between $42 of casein, lime, and linseed oil and the $24,000 weatherization project the industry assumes you will schedule every decade. That gap is $23,958 wide, and now it belongs to you. If this vault changed how you feel that draft coming through your window frame, subscribe and share this video. Every share puts a crack in the wall they spent decades building around knowledge that was never theirs to lock away. The next vault opens soon. And what is inside is the one thing every homeowner replaces every few years that a materials engineer in 1961 proved never needed replacing at all.